Hello everyone. Today we're going to go ahead and learn how to graph inverse trig functions. So go ahead and look at your notes real quick to review cosine, sine, and tangent. If you do already know them, go ahead and attempt this quick warm-up. If not, review for a little and come back to this warm-up. Go ahead and pause the video and give these matching a try. Okay, so hopefully you were able to see that, hey, these are just period for these A and B. These are just a period um, of what looks to be a sine or a cosine. They look a little bit confusing because they are just shifts of each other. But if we go ahead and look at the y-axis, right? If we look at the y-axis, we can go ahead and see that one passes through the midline and one passes through the maximum. So just by given that information, we can go ahead and see that the one that passes through the midline is our sine of x. The one that starts, or the one that passes through the maximum, is our cosine of x. Oops, cosine of x. And this one right here, the one that looks like a cubic function, and I know you can't see it really good here, but the vertical asymptotes as well. That right there is tangent of x. So let's go ahead and continue. This is for my students that are looking at a week ahead. This is what we're going to go ahead and learn. Tomorrow, for my students on campus, we are at half a day. Okay. Here we're going to go ahead and see how to graph these inverse trig functions. Okay. You don't need to know that that is for our game plan for tomorrow. Okay, something you do need to know. Okay, so this right here, hopefully you can go ahead and start thinking about, hey, how do we find an inverse? How do we find the inverse of a trig function? Well, we can go ahead and see that. Hey, we can get the x and y values, swap them, and then solve for y. So that's one method. Okay, we can go ahead and swap, oops, x and y, and we can go ahead and then solve for x. Sorry about that, my pen is not the best right here. Okay, so from here, that's one method. That's algebraically mostly. The second method is if you have a graph, you can go ahead and see that if I swap all my x's and y's, all of them, we get these coordinates, these x's and y's, and I go ahead and graph. Now, the points I go ahead and swap them, we can go ahead and see that, hey, now I'll have the inverse function. So we go ahead and graph the swap points. Okay. Now, depending how your professor or how your teacher wants, they might use two terms to do this. So for sine, its inverse is called arcsine. This is the inverse of the sine function that we just saw in the last slide. For cosine, we call it arccosine, or this cosine with, it looks like a little -1 exponent. Okay. That is the misconception. It's not -1. That's just the notation. Okay, tangent, we have arctangent. So you might see me using one or the other. I just want you to know that they are the same thing. Okay, so go ahead and pause the video and give these notes, write these notes on your notebook. Okay, so the same thing occurs. We're going to go ahead and graph the original function. So let's say we're doing sine, which we'll graph sine, then we'll swap the x and y coordinates, and then we will limit the domain. So I'm going to go ahead and talk about that in a little bit. So go ahead and pause the video and give these a try. Okay. Alrighty, so before we begin, I need you guys to be ahead and be familiar with the unit circle. Now, this is something we've written down in the corner of our paper for many times, but hopefully you know it by now. So go ahead and pause the video and give these notes a try. So fill in the unit circle. Okay, I'll do the same thing. I'll do a little bit quicker now that we've seen it so many times. And we have 1 and 0. This is for 0. This is pi over 4, right? It's exactly halfway up 90. So we have 1 and 1. This right here is pi over 2. This is 0 and 1. So all I'm doing, guys, is I'm noticing my coordinates associated with my radians. Now, some people choose to do with degrees, but that it should ideally give you the same thing. Okay, so this right here is -1 and 0. This one's -1 and -1 because they're both below. this right here, this is pi, then if I add another 1/4, that is 5 pi over 4, so 5/4, right? This is 3 pi over 2. This is 0, -1 is -1. I'm sorry, this is +1 to the right and 1 down, so -1. And then this right here should give me, this was 6, this would be 7 pi over 4. And finally, a full revolution is 2 pi. Okay, so keep in mind from here, guys, my x's are associated with my cosine of theta. My y's are associated with my sine of theta. So that is very important, especially when you're graphing cosine, sine, and of course tangent would be a y over x of these coordinates right here. Okay, so let's go ahead and graph sine. This is something we have already seen in our last unit. So go ahead and pause the video and give these a try. Okay. So hopefully you were able to see that sine is our y's, right? Our y's. So I'm going to go ahead and get the y coordinates and the y coordinates of all the points right here. Keep in mind, these right here, we're only going to use the critical points from the last slide, which are our 0 degrees, our 90 degrees, our 180 degrees, our 270, and our 360, right? So this right here is 90 degrees, which is pi over 2, then pi, then 3 pi over 2, and 2 pi. Okay, and of course, on the left-hand side, we have this being negative. Okay, from here, we know that sine goes ahead and starts at the midline, then it takes off to the maximum, then back to the midline, then to the minimum, which we know is -1 in height, and the maximum is 1. Sorry about that. And then back to the midline, and of course, this continues the same pattern. Keep in mind, to the left-hand side of the y-axis, we can see that it follows the same pattern, just backwards. So we can go ahead and see that, hey, this right here is my sine function. Hopefully yours does not look like thunderbolts like mine does. Okay, something like that, right? Keep in mind that I just did a little bit over a period, but this is something that continues and continues to go on again because we are going around the unit circle. Sorry about that. There's people talking right outside my door. Okay. Hopefully we got that idea there. What I want you to go ahead and do, and this is where we did in class, was the Peardeck, just so that I can see, do you really know how to find the domain and the range? So go ahead and pause the video. I gave you the graph of sine. I let you know that these right here are telling you that it continues till infinities. So go ahead and tell me, what is the domain? What is the range of these functions, of this function sine? So domain is all the horizontal, right? So all the x's. So hopefully you can see that, hey, this arrow is pointing to the left. So the farthest left I can go is -infinity. Similarly, this wave is continuing to go to the right. So the farthest I can go is +infinity. Okay. Now, the same idea happens for my range. Let me go ahead and use a different color. I said over here that the highest I can go is my max, which is 1, and the lowest I can go is a -1. So from what we just said, the lowest I can go is a -1, and the highest I can go is a positive. Okay. So then how does this affect us when we're looking at arcsine? Well, keep in mind, we just saw that sine is this graph that is a, oops, I keep doing, so, well, watch me. Okay, there you go. So we saw that sine is a horizontal wavy sinusoidal function that is just doing this sort of pattern. Now, if we were to do this, if we were to reflect this over the line y equals x, or swap all the x's and y's, right, we would actually get something that would look like this, right? Our graph, instead of it being horizontal, it will now be vertical. Now, I want you to think about something that's going to happen there. I set this graph right here, this relation. However, is this a function? If I was to go ahead and graph a sine vertically, It wouldn't, right? This does not pass the vertical line test. You can see that it fails multiple times. However, we can indeed limit the domain, which therefore would limit the outputs, would limit the range. And this is how it would look like. So if we go ahead and have this point right here, this point right here, and this point right here, and I'm not pulling these points from thin air. I'm actually looking back at our function that we just did, and we're going to actually be using these points right here. Okay, so we're going to go ahead and get this point right here is pi over 2 and 1. This one's 0, 0. And this point, negative pi over 2 and negative 1. So I'm getting those points. And as we said, we were going to swap them. So that's what I'm getting right here. So I should have something that looks something like this. Sorry, I'm going to really try to make this curved. Okay. And hopefully you're able to see that, hey, I can see it. Like I can see that this is a section of the function that was graphed like so, right? Wow, that's really bad. But hopefully you're able to see that, hey, these are the same points. So ideally, what we're going to go ahead and do is we're going to go and still get these coordinates. So this point right here, this is a negative 1. This is a 1. And then my max height is pi over 2. And my my minimum will be negative pi over 2. Okay. So ideally, these coordinates right here, this point right over here, and I'm gonna make it a solid dot because it does not continue. It ends here, is gonna be negative pi over 2. I'm sorry, not negative pi over 2. Negative 1, and the lowest it can go is negative pi over 2 as my coordinate right over here. Similarly, this coordinate right here is 1, and the height is pi over 2. And hopefully you're able to see that this right here is 0, 0. This is your origin. Okay, so this is what I meant by arcsine. Now keep in mind that you can also refer to it like this, but arcsine is perfectly fine. Okay, so let's go ahead and find our domain and our range. So pause the video and brainstorm about what our domain and range are. Okay. So we said in Unit 1, or probably in your Algebra 1 class or Algebra 2, that domain is all the values in the horizontal that are associated with the graph that we are given. So I want to go ahead and stress out this point right here and this point right here. We know that the graph ends in those points. It is restricted. It is limited to these points. So therefore, the only interval that this graph exists is from to the left, negative 1, all the way to the right, right? On the horizontal is that. So that's how far you can go to the left. That's how far you can go to the right. The range, however, looks a little different, right? We were expecting numbers, but instead we got radians. So the lowest I can go still is this point right here, which is the lowest point is negative pi over 2. And the highest point is pi over 2. Now, a lot of students get a little bit intimidated on why there is a pi on this domain and range. Most of the time they have not seen it. But what I want you to know is that pi, 3.1415, so on, that is a number, right? This is pi. So ideally, if you have a pi over 2 or a pi over 4, you're still going to go ahead and do some sort of number still, okay? So just know that that is still a number. Some students even write it in degrees, which is a little bit more odd, but ideally you're still seeing that this is still a number. We can still find domain and range for them. And it will be pretty useful, especially when we are working with inverse trig evaluation. Okay, I got a little meme for you guys. Arcsine, it's pretty blurry on the white. Is the same thing as arcsine. They're both inverse as well. So let's go ahead and graph cosine. So I'll do that with you, but go ahead and try it on your own first. Cosine, we're still doing the same. We're still increasing by pi over 2, where as students like to call it 50 cents. 3 pi over 2 $1, and then this right here will be $2. And on the left hand side, you just have it in negative, the same numbers. So Ideally, what we're looking at is a function that starts at the max, which we said is 1. Then it goes to the midline, then goes to the minimum, which is -1, back to the midline, then back to its max. And then if we do that same thing on the y-axis, right? Y-axis, the values just go ahead and continue, but now the reverse of the pattern, right? So we have something like so, and let me see. Hopefully this time I don't do thunderbolts. All right. So we have something like so. We have this graph right here that we will call cosine. Now I didn't pull this from thin air. I'm using the x values of these critical points, which we went ahead and filled out, right? Alrighty. So let's go ahead and start on our inverse, our inverse function. So if I have this cosine, right, which is a sound wave, right? It looks like a sound wave that is just repeating both on towards positive infinity and towards negative infinity. If I go ahead and replace all the x and y values, now my horizontal line is a vertical line. And as you guys saw, it's going to go ahead and be very tough for this to be a function because this will not pass my vertical line test. Okay, so therefore we must limit the domain. So go ahead and think about that. How will that be limited in our domain? Well, from here, hopefully you were able to see that if I restrict it from 0 to pi, I can go ahead and see that this right here will be my function. So something like so. Let me see. Hopefully I don't do nothing. There you go. There is curvature. Awesome. So this right here is my arc cosine. Now we limited it on its domain, so therefore now its range is going to be from 0 in height to its max height of pi. Therefore, when it passes right here at the y-intercept, that is pi over 2. And if we consider the coordinates that came from that, those were -1 and 1. Okay. From here, we can go ahead and find the domain. So let me go ahead and go to that slide and find the domain of this. So how far left, how far right can we go to find this domain? So hopefully you're able to see that this red graph still has these points right here, right? And the farthest left we can go is -1, and the farthest right I can go is 1. It is limited, it is restricted to those parts of the function. Okay. So notice how the graph cannot go any more, that can't go farther to the -1, because if it does, its range will be a value that we already know. Meaning, let me go ahead and draw it for you. Hopefully I don't confuse you. Ideally, this graph right here will eventually be doing something like so, right? So that's why we cannot continue the domain. So the range we saw is from 0 to the highest I can go, which was pi. Okay, because keep in mind, if we go farther than that, then the y values repeat, and that will cause this to not be a function. Okay. Alrighty, the next one that I want to go ahead and do with you guys is tangent. So tangent is very interesting because it has vertical asymptotes at x equals pi over 2 on the -pi/2 and at pi over 2. Now I want you to think about that. What's going to happen with these vertical asymptotes when we go ahead and get the inverse? So we know what happened with our horizontal wave. It became a vertical wave. So what's going to happen to vertical asymptotes? Okay, so think about that. I'm going to go and continue to fill this in. This is negative pi over 4. This is pi over 4. This is pi over 2, a vertical asymptote. This one is with a 4, I'm blanking out, 4 pi over 4, 4 pi, 3 pi over this right here will be our pi. Not to worry. So we have something like this. Let me make it in green. We have something that is coming from the vertical asymptote. Then it passes at negative pi over 4 to 1. Then through the origin. Then when pi over 4 is my x value, my y value is 1. And then all the way to infinity. This is something you are not familiar with. This is how to graph tangent in my videos and in your notes. Okay, so we have something like this, and the pattern, as you can see, it will continue to go ahead and do this since it is copying the unit circle. It is behaving based on the unit circle, and we can go around the unit circle as many times as we want. Okay, so we have something like so. Alrighty. Now we can go ahead and see that the domain is very interesting here because of the vertical asymptotes. It's all real except whenever we have vertical asymptotes. In this case, pick one, x equals negative pi over 2. And every period, which is pi, it will repeat. So where k is an integer. Okay, so we can see negative pi over 2. I add pi, I got pi over 2. Okay, and if I continue doing that, I'll have another one at 3 pi over 2, and so forth. Okay, the range, however, the range is going to be from the lowest thing, go negative infinity, all the way to positive infinity. Okay, and that is denoted by these right here, these arrows. Oops, I forgot to draw. Okay, so we went ahead and talked about that. Now I want you to think about what's going to happen when we find the inverse. Well, now we saw that we had the graph going up. So if we go ahead and rotate everything 90 degrees, or the same thing as reflecting it over y equals x, or just swapping all the points, hopefully you're able to see that my vertical asymptotes are now turned into horizontal asymptotes. So right here, these values that you saw at pi over 2 are now horizontal values. So we got a horizontal asymptotes at y equals pi over 2. So we have all of this right here. These right here were the other ones, which were my horizontal asymptote at y equals negative pi over 2. Okay. Now this isn't where the graph, this isn't all for the graph, so keep in mind we still have that the tangent function exists inside these. So this right here, this graph is limited and very restricted to these horizontal asymptotes. And we can go ahead and see that this right here is my arctangent. So just make sure you have your arrows. So we have something like this. Okay. Not to forget that these points are still true to the function. So let me sorry about that. These are our pi over 4s, pi over 4. Now, from here, we can still find the domain, we can still find the range, and it works exactly the same. Okay, so the domain, how far left, how far right can we go? Well, keep in mind these right here, these arrows are telling me that I can go as far left as I want and as far right as I want. So negative infinity and positive infinity. Where it does get a little messy is range. Range, because we are limited to those asymptotes on the top and the bottom, the lowest I can go is this asymptote, and the highest I can go is this asymptote. So pi over 2 negative and pi over 2 positive. I'm going to go ahead and stop this. Hopefully you know that we cannot pass these asymptotes. So therefore, when I talk about the if pi over 2 is included, we cannot say that. So this is not including the horizontal asymptote. We cannot physically put a point on these asymptotes because the graph will approach it very close but never cross it, so therefore never actually have a point at y equals pi over 2. Okay. All right, for that is pretty much all that I have for our introduction to graphing these arc functions, these inverse trig functions. I do have a pretty good practice, so I encourage you to give this a try. This will be due on Thursday at 5 p.m. If you do have questions, please reach out to me. Due to the half day, I don't think I'll have tutorials, but if anything, please reach out to me and I'll give you the best answer I can. Okay, as always, guys, it's been a pleasure and thank you.